All right, we're going to continue on talking about transformations of graphs, and this time we're going to talk about a stretch or a compression of a graph. And this is an interesting idea. If we were to think of taking the y value and basically sort of think of like your graph as a sheet of rubber, and you were to sort of stretch that sheet of rubber, all of the y values would kind of elongate. You'd end up with kind of narrower shapes. Or you could also compress things and make them kind of a squatter, fatter shape. With this, with a stretch, all we're doing is we're increasing, we're multiplying our y values. So the ratios change a little bit, but all in all, they stay, the general shape stays the same. It's just, it gets distorted in this vertical direction. So a stretch is when we're going to, this is when we're going to multiply the y value by some number greater than 1. And I'm going to call this stretch factor like a. I'm going to say that's going to be greater than 1, because if it's equal to 1, obviously you're the same thing. So for a vertical stretch, we're going to multiply whatever our function is times something. A compression? Well, compression is interesting because it's going to be, we're going to be kind of cutting it down, but we're not going to flip it. It's not going to be negative. So a compression is where we're going to multiply this again by some factor, whatever our function is, but this time we're going to multiply the y value by a number between 0 and 1. So here we're just taking whatever that ratio is and we're going to make it smaller. So let's show you what we're talking about. For now, I'm going to say f of x is equal to x squared. This is a really common kind of thing that we're going to work with. So let's look at this particular thing. Let's see what our basic function looks like. So for our x and our f of x, if I were to, we tend to think of 0 as kind of the center of these things, so I usually work out from there. If I were to take the square of -2, I'd end up with a 4. The square of a 1 would be a 1. Square of 0 is 0. 1, 4. And if I were to continue this trend, I would end up with 9 and so on. Well, let's see what happens if I were to multiply this. Let's say we've got some other function. I'll call this g of x is equal to, let's just double all of these values. So I'll have 2 times that x squared. So I'm going to, basically, all I'm going to do is double everything that I have here. So for my g of x, I'm going to be, if I were to say, well, what happens if I do this? I will have, my g of x would end up being, g of -2 would be 2 times -2 squared. That's going to be 2 times 4, or just an 8. Yeah, this just doubles that value. Here this would be 2 times 1 squared, which would be a 2. 2 times 0 squared is still 0. 2 times 1 squared is 2 times 1 is just 2. 2 times 4 is 8. 2 times 9 is 18. So on. Well, that's interesting. There so that's that. So that's a stretch. What about a compression? Well, probably should have wrote this a little differently. Let's take a look at something. We'll call this h of x. And this time, instead of doubling these values, I'm going to actually take only half of them. So h of x, this is h is, so that half is in between 0 and 1. That's going to be 1/2 of that x squared. And now, when I do that, I would, once again, I'd be taking half of whatever I'm plugging in, or half of my squared, half of this f of x. So h of -2 is going to be 1/2 of -2 squared. That's just going to be 1/2 of 4. That's going to end up being a 2. Half of 1 squared, that's just going to be 1/2 of 1. That's going to be 1/2. Half of 0 is still 0. Half of 1, 1/2 again, 2. Half of 9, this one's a little tougher. Well, not that tough, but it's probably bears showing. H of 3 would be 1/2 of 3 squared, or that's going to be 1/2 times 9, or 9/2. This would be about 4.5. Well, not about 4.5. It would be exactly 4.5. So let's graph these and show what these different shapes look like on a graph. So since we're going to be very careful with our scale here. I've marked this out this time, and let's take a look at our parabola, that basic function of x squared. So we said when x was -2, it was 4. So we'll go 1, 2, 3, 4. When it was -1, it was 1. 0 is 0. 1 is 1. 2, 3 squared is 9, so it's 5, 6, 7, 8, 9. And we'd see symmetry over on the other side. So I would expect a graph to look like this. So this right here is our x squared function. Well, now let's take a look at that 2x squared. So when I had a -2 in here, I'm taking all of these x values, so this 4 is going to double. So 2x squared would be 8. So 4, 5, 6, 7, 8. 2 times 1 squared is just going to be 2. 0 is 0. And once again, we've got that symmetry. So what happens is this. We've got a much narrower parabola. This is that 2x squared. So it's like we took this original parabola, and if we could sort of grab these things and stretch them out, it stretches, it distorts this in that y direction. Well, okay. What about our half? Well, when I did half of that 2 squared, I ended up with 2. Half of 1 squared is 1/2. Half of 1 is 1. And half of -2, half of -1 squared is 1. So 1/2. And let's see here, we went out to the 3, we came up with 4.5, so that's 1, 2, 3, 4. I'm going to have to go in between my 4 and 5 marks here. I could probably even continue this out. 4 squared would be 16. Half of 16 would be 8, so I've got 5, 6, 7, 8. 25, half of 5 squared is 25 half of 25 is about 12 and a half. Well, once again, exactly 12 and a half. So 5, 10, 11, 12 and a half. So I could actually get many more points on here with this one, but you notice that we've got a broader parabola. It's like we've flattened this out a little bit. This is this 1/2 x squared function. So now we see what happens when we multiply one of our basic functions by another value. If it's by something bigger than 1, it elongates it. If it's by something smaller than 1, it flattens it. Something different altogether happens if we multiply it by a negative, and we would discover that later would actually flip this across the x-axis. Anyway, that's what we have time for right now. We will catch you in the next video.